Hey guys, my name is Jani Sarjoloma and this is OptoFidelity Test Corner. We are here at the SPIE AR/VR MR conference and would like to show you guys some highlights from here. So stay tuned. I have Tobias here from TechnoTeam. Welcome to the show.
Hello Jani, welcome to the show.
So can you tell the audience a little bit what TechnoTeam does?
TechnoTeam is a manufacturer of luminance and color measuring camera systems. We call them LMK.
So now that we are here in AR/VR conference, I see that you have something here that has an AR device on it. So what are you guys showcasing?
Here at this booth we are showcasing our newest LMK 630 color camera in combination with our own developed LED metrology lenses.
So I can see that you guys have placed the lens where the eye would go. So how is that lens somehow specially designed for this purpose?
Yeah, of course, you're right. The lens is designed to utilize a front stop aperture that is necessary to reach the eye point position of AR headsets.
Got it. And then do you guys sell these systems or basically instruments to somebody who will then integrate them into the measurement systems?
Yes, you are right. We are selling the systems to our customers and they do integrate them into testing stations, or our distributor network is supplying the turnkey solution as a system integrator.
Got it. Well, hey, thank you for coming to the show. It was so good to talk to you.
Yeah, it was a pleasure.
Yeah,
thank you.
Take care.
So I'm here with Jukka from INKRON. So Jukka, can you tell us about what INKRON does for AR industry?
So INKRON is a materials producer for AR waveguides. So we have a high refractive index nano-imprintable resin, optical black materials and cap filling materials for etched AR waveguides.
So within the last 12 months, we have seen a lot of mergers and acquisitions happening in the AR/VR industry.
Exactly.
Can you tell us some examples of that too?
Yeah, I can show myself or INKRON as an example.
Yeah.
So INKRON was recently purchased by Radiant Optoelectronics Taiwan, and I guess that for the industry in general, this activity is a good sign. Market is maturing, it's getting bigger, and then this vertical integration starts happen, and we are a prime example of that. So we will support the Radiant mass manufacturing capabilities in the area of AR waveguides.
Yeah. So this year, have you seen some exciting new developments during the show?
Well, I think that the biggest thing on the tech side is the silicon carbide waveguides, which are definitely coming. Of course, there's still a price issue, but I'm sure that given a few years, it's going to be there.
And your materials would work for any substrate, I guess?
Well, it depends on the material, but like, let's say, edge blackening to control internal reflections, cap filling, and things like that, we can work with any substrate.
Okay. Well, thank you very much, Jukka.
Thank you.
Yes.
I'm here at the OptoFidelity booth. I have Jonas here. Welcome to the show.
Thank you. Thanks for the invite.
So just for the audience behind the camera, what does OptoFidelity do?
So OptoFidelity is a Finnish-based company making custom testers for various use cases, but I'd say our biggest is now we are focusing on the AR, VR, XR world. So image quality testing, grading testing, full headset level testing.
So now that we are here in the AR/VR conference, what is new this year?
So what we have new this year, actually behind me as well, is the OptoColor RX, so our new camera system that is able to adjust to the different prescription lenses.
So what does that mean?
So what it means from technical point of view, we can adjust for the spherical prescription or RX and the cylindrical prescription. So meaning that besides the regular kind of a focus as you think of it, we can also adjust for the anti-stigmatism of lenses. So if you would have a waveguide that has integrated RX on it, with this camera you would be able to measure it exactly like the user would see it with their vision correction.
Oh, got it. So basically you are able to simulate the human eye illnesses.
Exactly.
Got it. And then when would you need something like that?
So depends on the level of the production process, how it's been set up. So usually after the waveguide level, you might be integrating a prescription lens to the waveguide. So then you would probably need to test for the image quality, that the lens is not actually having a negative effect to the image quality of the waveguide. Then another would be that if you have, let's say, curved waveguides, or the waveguide already is shaped like a RX lens, you would test that immediately, the effect there.
Got it. And then you can basically, I guess, have this lens in any kind of testing equipment that you guys make.
So the testing lens behind me, it's available for WGIQ, so our kind of R&D low volume image quality testing, also for the production IQ, which is a production scale platform, and also for system level testing. So if you have a full headset that already has a RX lens inside it, like AR glasses, VR headset, XR headset, that's available for that.
Okay, thank you, Jonas. It was good to talk to you.
Thank you.
I'm here with Brian from Nil Technology Denmark. So Brian, can you tell us about Nil Technology?
Yes, of course. So Nil Technology is a company producing meta optical elements, and this year we have launched a meta eye camera, so we can talk more about that later. We're also doing masters for AR, so that's why we have a booth here. But we also have a booth at the Photonics West to show all the meta optics elements.
What exciting stuff you have seen this year from SPIE AR VR side?
Well, I think it's there's always progress in the AR side. People are showing more and more real glass-like components and systems. I think that's interesting. I think Meta had a presentation yesterday really outlining the targets for this industry. I think that's exciting. And then of course we see a lot of opportunities with the Meta eye camera for eye tracking, which is an important part of that ecosystem. And we also have a demo here with Pupil Labs, where people can see an actual system with the whole system actually doing eye tracking with algorithms and everything.
So I've seen that the general consensus is that people are expecting 2027 will be the year that you will see more high volume production for actual AR smart glasses. Do you agree on that one?
It could be right, it could be wrong. I'm not sure. I think there's a lot of stuff happening, but if that's, yeah, I'm not certain.
Well, thank you, Brian, for your time.
Welcome.
Yes, pleasure.
I'm with Heini here from dispelix. Welcome to the show.
Thank you. Happy to be here.
So pretty much everybody knows what dispelix does, but can you just with a few words tell what does dispelix do?
Yeah, so dispelix is specialized in designing and developing diffractive waveguides for different AR applications like AR glasses, head-up displays, and so on.
Okay, and then now that you are here in AR VR conference, what is the biggest new thing that you are showing?
So the biggest star definitely has been our silicon carbide demo with a 50 degrees field of view. So that has been something that everyone has been looking forward to see and have been amazed about.
Got it, yeah, because I have noticed that silicon carbide is something that everybody are talking about. So what is so great about that material?
So the material has higher refractive index, which enables you to go into larger field of views.
Yeah, so basically you can fit more material, of course, in the picture, but then when you have wider field of view, then people can, well, just basically see more.
Yes.
Yeah. And I guess that's always something that people are talking about. Hey, can we get field of view that covers my whole eyesight, basically? So now we are basically getting there. Yeah.
We're providing the opportunity to go there. So yes.
Yeah. And I actually saw the demo earlier, and it was really nice to actually have that bigger field of view, because it felt more like you were there.
Yeah.
Yeah.
It's definitely more immersive.
Yeah. Well, I can't wait to see those in the real products. So now it's of course a demo, but maybe, I don't know, maybe in a year or two it will be somewhere in the real product then. So, Heidi, thank you. It was so good to talk to you.
Thank you.
Yeah, thank you.
So I'm here with Matthias from SCHOTT. So SCHOTT is a very large organization. They do a lot of stuff. But what does SCHOTT do for AR industry?
So in AR industry, we basically follow two aspects. One is we provide glass wafers for SRG waveguides, and for reflective waveguides, we build a special factory. We manufacture the waveguide based on Lumos design, and our facility for this is in Kulim in Malaysia.
So SCHOTT provides substrates for the diffractive waveguides, and then SCHOTT also manufactures geometrical reflective waveguides by themselves.
Correct.
So is there some sort of comparison that you can tell us, or which one is closer to the actual mass production? What do you think?
Basically, both technologies have their right to stay. So from our point of view, there is no, let's say, one is closer to MP than the other. We basically produce the waveguide by ourselves, while the wafers are kind of a basic material only, and that basic material is also in mass production. Yeah? So the new things about SCHOTT and GR waveguides are that the facility in Kulim is already in stable mass production at very good yields, and basically you can see already products with our waveguides in the market running around on the show.
Yeah. Maybe a quick question about the production. So we are seeing that most of the production is happening in the APAC region, but I don't really see any mass production facilities building their lines in the Europe, for example, mainland Europe. Do you expect that in the future there will be also mass production of waveguides in Europe?
It's a good question, but difficult to say. Right now, why did we select Malaysia to have our production site there? It's because we already have a big footprint in optical glass processing. And many of the know-how that we use is there, so we can also leverage it for the AR production, right? So, time will tell. Difficult to say now.
Okay. Well, thank you, Matthias. Pleasure.
Thank you, Murat.
So I'm here with Erhan from MORPHOTONICS. So Erhan, what does MORPHOTONICS do for the AR industry?
We help scale the market to the next level,
All right.
to millions of waveguides that are required to make this a market that can really stand on its own.
Okay, so how do you guys do that? Do you have some tools, machinery, or the process?
Yeah, we are a company that's based in the Netherlands, right down the street from ASML. We are a panel-based nano-imprint lithography solution provider. We basically can replicate very complex structures like AR waveguides at a panel level, with, in this case, multiple wafers being imprinted at the same time that can help really increase the throughput to millions of waveguides a year.
Okay, so basically you manufacture a system which is enabling you to multiply a lot of replication process for the waveguides, so that they can have many waveguides for much lower cost.
Exactly, that's the idea, because the current manufacturing methods are all based on a semiconductor manufacturing mindset. But we come from another angle, more from a display manufacturing mindset, where panel-based manufacturing really can make a difference in reducing the cost and increasing the throughput.
So the panel-based means that you are not really limited at the size of the wafer, so you can go beyond the size of the wafer.
We can, but the industry, the substrate suppliers cannot really keep up with that, because what you need is a high refractive index glass to have the right efficiencies and performance. In our case, we are limited by 300 millimeter squared wafers at the moment. What we can do is we can pluck basically multiple of these in pockets, where we can do wafer level imprinting, multi-wafer carrier-based imprinting to increase the throughput. Okay,
so you mentioned about the high refractive index. So I have seen a lot of demonstrations with the silicon carbide as substrate, which is having about 2.65 Ri.
Yes.
So is that the way that the industry will go when they are trying to achieve the Ri as a high
So it's a design choice, right? I mean, you can have a narrow field of view, and that can be limited with the current high Ri glass and polymer substrates. But if you want to go the wider field of view, like 70 degrees, that's where silicon carbide comes in. We don't care, because at the end of the day, we are agnostic. We can use, basically, instead of putting in glass wafers, we can put polymer, we can put silicon carbide, and still be able to basically put a waveguide structure on top of it.
Yeah. So together with you guys, we are also part of the AR consortium.
Yes.
Would you like to say a few words about the AR consortium?
So everyone gets confused when we talk about the AR consortium, because there's AR Alliance as well, right? The AR consortium that we put together with you and with OptoFidelity and others 5 years ago is completely a loose consortium of partners that came together to show the feasibility of high volume manufacturing. But the AR consortium showed end-to-end from design all the way to singulation, the manufacturing of waveguides, and we are continuing to publish very nice data and technical papers at SPIE, and we'll continue to do so, but this doesn't mean that we cannot be part of the AR Alliance.
Yeah. Well, thank you very much, Erhan.
Thank you.
Pleasure.
Thanks.
Yes.
Oh, and then lastly, we again have a new tool called the Cypress X600. This tool basically can enable up to 6 million waveguides production per year, and that's a new announcement that we have made for MORPHOTONICS.
Well, sounds really exciting, Erhan.
Yes.
Thank you very
Thanks.
much.
Appreciate it. Thanks.
Yeah.
That was it for 2026. See you guys in the next one.